So what do you think 2 to the 7th divided by 2 to the 3rd looks like, or what does that mean? Well, let's get a sense of what's happening here. Remember 2 to the 7th? That's 2 times itself, 7 times. Two to the 3rd, likewise, is 2 to itself, 3 times. Notice that there's some factors on top and on the bottom that I can factor out. I can cancel those 2's out, those 2's out, those 2's out, and I'm just left with 2 times 2 times 2, which equals 2 times itself 4 times. So it looks like I have a pattern that I can build right here that suggests that if I have some b to the m over b to the n, that's going to equal b to the m minus n. Because notice 7 take away 3 produces a 4. And this is true when b does not equal 0. Just have that little caveat in there to make that sense. So let's use this idea to help us simplify some types of some problems here. So 2 to the 8th. So what do you suppose 2 to the 8th is divided by 2 to the 4th? Well, that's going to equal 2 to the 8 minus 4, which equals 2 to the positive 4. So notice, like we did with multiplication, we added their exponents. So with division, we're subtracting their exponents. It's kind of a cool type of an idea. X to the 13th divided by x to the 3rd. How do we think about that? Or we're kind of factoring out, well, let's write it this way. X to the 13th minus 3 and equals x to the 10th. Kind of factoring out x times x times x. And then lastly, y to the 15th divided by just a y. How do we look at that? Well, let's understand what the exponents are. Y to the 15th is 15th. What's this exponent to this y? It's just a 1. So let's subtract that one out. And then what's left is y to the 14th. Again, it's going to take a little bit of practice keeping straight. How do we know when do we add exponents, subtract exponents, and so forth? With practice, it will become second nature. With practice.